Hello everyone. In this video, let's talk about an interesting problem. So this is a problem from practice challenge of HackerRank in the section Java string, and the problem starts with the definition of anagrams. Two strings A and B are called anagrams if they contains all the same characters in the same frequencies. Now there are examples: cat, ACT, TAC, ECA, ATC, CTA. So it's not case sensitive for the purpose of this challenge. We need to consider both the cases, but capital C and small c are counted as a single character equivalent with respect to checking whether a string is anagram or not with another string. So there's a function which we need to complete, which calls is anagram, which returns uh, message, which is if the two strings are forming anagram, then it says anagrams. Otherwise, it should say not anagrams. And the length of the strings will be between 1 and 50, and input is provided in the form of two strings entered through standard input separated by new line. So there is explanation of the solution. For example, this is anagram and margana. These are the two strings. They are said to be forming anagrams because if you see the frequencies, A is 3, G is once, N is once, M is once, and R is once in both these strings. And notice they have same number of characters, exactly same characters with same frequencies. And there is another example here, anagram with double M, and there is Makana double A, one A additional. So here you see A has different frequency 3 and 4. Although the number of characters are same, what are unique characters A, G, and M are, but there is difference in the frequencies of M and A. So, this string should be said not anagrams. Another example, there is a capital hello, H capital, and the other one is hello with H small. Here, since both small and capital letters, we don't consider the case. They are counted as the same character. They both strings forms anagrams. So here is uh, the explanation. So they contain E, H, L, O, these strings, and this is the frequency. So one solution quickly which comes into the mind is first let's take the string, then you short the characters of the string. So first convert the string to a character array and then short the array and finally match both the strings. If they are same, then that means it's anagrams, otherwise not. But this will take log of n log of n complexity because you have to short both the strings. Each of them will be taking n log n time because shorting is what you do. So yeah, this is not very efficient solution because you have to sort the strings, which has additional complexity. We should think about an algorithm which could be of linear time. You definitely need to traverse the string once to know different characters, and you can't further optimize below linear complexity. So we can create hash map and store each characters and their frequencies. But again, is data structure where you require some hashing function to be executed. So to further simplify it, we can just use a character array of integers, and we can just create the indices as per the ASCII values. and then as we encounter any character in the first string, we fill in the values, increment the values in the corresponding places, and in case no we no encounter the same characters in the other string, we start decrementing the values, and at the end we can check whether the entire array has value 0 for all the characters in that particular array, integer array. So let me draw it and show you. So to illustrate this, no, we have 0 to 20. These are the indices 0, 1, 2, 3, 4 until 25. We can think of a mapping which is for each app. So we have A has 0th place, B is one location, C is the second location, and so on. So when you encounter, say for example, A in a string, no, initially we have all the values set to zeros, and then as you encounter, you set the first location as 1, and when you encounter some other character, say D, you increment the fourth and this, and then you traverse through the first character and fill all the array elements. And once you have done with the first string, then you repeat repeat this process with the second string as well. But this time, instead of incrementing, you start decrementing the values. So in case you see A, you decrement now 2 to 1, and then if you encounter D, you decrement it back to 0, and if you get again 1, then and then just check if the entire array is 0. This way, you would be able to use only one array, and you just have to traverse it three times, once for the first letters, other time for the second string, and at the end, whether all the elements of the uh, all the elements of the array has zeros, and if any of the element is non-zero, then you say not anagram, otherwise you say anagrams. So let's write the code for it. There is already the code to read the input is already provided. So as I said, no, we have found there are two strings A and B. So first thing is, since we don't have to consider the casing, we have to convert these strings to lowercase. So I say to lowercase. So this way, both the strings will be considered only in lowercase. In case there is any uppercase, converted to lowercase. So this will be treated as like this. So there's one advantage. Then, as we said, we have to use since there are only 25, or so there are some characters, 26 characters only. We have to consider only alphabets, English alphabets. So we can create an array of size, say 26, and this way we will have corresponding location for each of the characters. Now, in this particular problem, it's specified both string A and B are having at max length 50. So, even integer is little longer, so we can use byte instead, because it can use up to 127 minus 127 to plus 127, which is sufficient. Now, what we need to do is we need to iterate and over any string. So in this case, int I equal to 0, I less than, I would say, a dot length, whether it's a dot lowercase dot length or a dot length, so both will be having the same length, and then we say I plus plus. So now before that, if the two strings are of different length, then definitely they'll be they'll not be anagrams. So the quick check, first which we can do is a dot length is equal to a dot b dot length. So this property. A and B are a string, and string is an object, so length no method we need to call. So here, if they are not equal, we can just place this condition, and we return false straight away. So no need to do any processing. It's straightforward. If two strings are of different lengths, they cannot be anagrams. Now the other thing is, once we are iterating, so we will encounter two lowercase and then say character at I. So this we will get some character. Let's say this character is ch, char ch, and character at. So once you get this character, we need to see the count for this character. The count of the character is no the index where we need to store this value. We can get it by using this expression ch minus a. So if it's a, then it will come at 0th index. B will have a value of ASCII value which is 1 greater than a, and so on. So in ASCII or Unicode, Unicode is the standard which is used for storing strings in Java. So A is represented as value 97, and B is 98, and so on up to no 122. So this way, we get the index where we have to increment the value. So our index for the array alphabet count, and then we kind of increment this. So this is what we do for A. Again, we can replace this. No need to use a separate variable. So you would have this for the first string, and for the second string, you can do exactly the same, but here you go and you implement the value. So b dot to lowercase dot character at I, and then here we say decrement by using minus points. And then this is yeah, this is now also redundant because we are doing lowercase here. So I just remove this. So I need a byte array of alphabet count, and then at the end I need to just go. So I will say byte, I say number in alphabet count, and then just we need to check if num is not equal to 0. We simply return false. Otherwise, need to do nothing, and then at the end return true. So this is the code for whether two strings they are anagram or not. So let me run this code to see if there are some errors or no. So there's no errors. There are three test cases which were provided. They are passing successfully. So now let's run this for more number of test cases and submit the code. See if it works in all scenarios. So here now there are many number of test cases, and it's running against each of them to see what's the output. Hope it succeeds. Yes, it got successfully completed, and this is most efficient and compact code for finding where the two strings are anagram. Hope you enjoyed this problem. It is very interesting problem and a good exercise, and it shows how we can simplify the implementation. We don't have to go with collecting classes, and sometimes you can use arrays, and that will give you more efficient, faster execution. So thank you. We'll see other problems later.